All right, as promised, today's lesson is still based on the fundamental counting principle, but it's a little bit more challenging to think about how many options you have for each event. So first of all, my son Jeremiah loves to build Legos, so I had to create this example for him. How many ways can he build his 7 Lego sets if he wants to get Batmobile and Batcycle done first? Okay, so he's got 7 different Lego sets, but how many choices does he have for the first Lego set that he's going to build? And the answer is 2, because he wants to choose either Batmobile or Batcycle first. So he only has 2 choices for his first Lego set. Once he's chosen one, he only has 1 choice for the second Lego set. So if he chooses Batmobile first, then the only option for the second Lego set is Batcycle, and vice versa. Now, he's already built 2 of his 7 Lego sets. So for the third Lego set, he has 5 choices. For the next one, he's got 4 sets left he hasn't built. And then he has 3 sets and 2. And finally, he only has 1 set left to build. So again, notice there are 7 different events that we have multiplied together, but the number of choices for each event has been a little bit different and a little bit harder to think about than it was yesterday. So he built all 7 Lego sets, so he had 7 events, so we should have 7 numbers being multiplied together. And then we thought about how many options did he have each time, which would give us a total of 240 different possible ways that he could build his Lego sets. All right, this one we are looking for how many different phone numbers can we create. Now, when you get assigned a phone number, the first digit in your phone number is not a 0 or a 1. So again, there's 7 different events, there's 7 different numbers, and we're going to think about how many options do we have for each digit in our phone number. So for the first digit, if it can't be a 0 or a 1, that leaves us with 2 through 9, which is a total of 8 different possible numbers. 2, 3, 4, 5, 6, 7, 8, 9. It's a little counterintuitive because 9 minus 2 is 7, but you have to include the 2. The subtraction does not include the 2. The other way to think about it is that we have 10 single-digit numbers. We've got 1 through 9, which is 9 total numbers, plus 0, which gives us a 10th option. So we were cutting out 2 of the 10 options, leaving us with 8 left. Now all the rest of the digits can be any number and they can repeat. So now we have all 10 options for the second number, and the third, and the fourth, and the fifth, 6th, and 7th numbers, digits in our phone number. I don't want to confuse that. We have 10 options for each digit in our phone number. So this is a total of 8 million different phone numbers. Oops, I lost a 0. All right, and that's within each area code. So think about what happened once cell phones became big. The number of different people that wanted a phone number within each area code grew exponentially. So actually when I grew up, there was 1 area code for all of Minneapolis, St. Paul, and its suburbs. The only area code was 612, whether you lived in St. Paul, whether you lived in Blaine, whether you lived in Hastings or Cottage Grove, they were all 612. And then, as there was more demand for phone numbers, they needed to split up and create more area codes for the Twin Cities. All right, now we're creating a passcode. It has to be 3 letters followed by 2 numbers. So notice that we have 5 different, I'll just call them digits, that we're going to be typing in for our passcode. So for the first option in our passcode, there are 26 letters in the alphabet. Now in a passcode, usually you can repeat. So we have 26 letters for the second digit and 26 letters for the third digit. Now it says 2 numbers with the digits 0 through 9. Well, we just counted. There's 10 different possibilities for the numbers 0 through 9. This gives us a total of 1,757,600 different passcodes if these were the conditions we had to choose our passcode from. All right, now I want you to try this one. I'm going to give you a little hint. It's a 6-digit passcode, so you should have 6 numbers that are being multiplied together. You have 6 options. How many choices do you have for the first digit, and then the second, and then the third, and so on? So give this one a try, and then we'll go over it together. For the first digit, it says the first number cannot be a 0, so that gives us the options of 1 through 9, which is 9 choices. It also said the same thing for the last, so I'm going to go ahead and put that down for my last option as well. Now the ones in the middle, it doesn't say that we have any restrictions on those, so we have 10 numbers to choose from for each of those in the middle. And that gives us a total of 810,000 different passcodes. All right, I hope you're having a great day. I hope you're doing okay with these counting principles so far this week. Please reach out to me and let me know, especially today's assignment. It is going to be much more challenging than yesterday's, so let me know if you need any help.